Okay, welcome to another video in the Python for DevOps book reading series. This is chapter 11, Container Technologies, Container and Docker Compose. Virtualization technologies have been around since the days of IBM mainframes. Most people have not had a chance to work on a mainframe, but we are sure some readers of this book remember the days when they had to set up or use bare metal server from a manufacturer such as HP or Dell. And I laugh when I read IBM mainframes because I have another video on here in my series on machine learning where I kind of go into the history of IBM. But I think mainframes are a bit later on. Like IBM like punch card systems, I think came before uh, mainframes. So I guess I'm not exactly sure what they mean by the term IBM mainframes, but I guess that just the main takeaway from this part is that virtualization technology is not a new technology. Um, these manufacturers are still around today, and you can still use bare metal servers hosted in a co-location facility, like in the good old days of the dot-com era. When most people think of virtualization, however, they do not automatically have a mainframe in mind. Instead, they most likely imagine a virtual machine, VM, running a guest operating system, OS, such as Fedora or Ubuntu, on top of a hypervisor, such as VMware ESX or Citrix-XGen. So that's kind of what I have. So I'll pull up my lab and we'll look at the virtualization I'm using in my lab. So I've got KVM Linux in my lab, and then this is kind of the main um, project I've been using. So then I've got these like VMs um, on there. I also have Docker containers. But let's get a Ubuntu, yeah, Docker guest up there. Oh, and I can't, yeah, I can't open it. Oh, oh, this is an Ubuntu Docker guest. So I've got, so this is a Docker container, not a VM. The big advantage of VMs over regular bare metal servers is that by using VMs, you can optimize the server's resources, CPU, memory, disk, by splitting them across multiple virtual machines. You can also run several operating systems, each in its own VM, on top of one shared bare metal server instead of buying a dedicated server per targeted OS. Cloud computing services such as Amazon EC2 would not have been possible without hypervisors and virtual machines. This type of virtualization can be called kernel level because each virtual machine runs its own OS kernel. Yeah, so that's a big advantage of using VMs over bare metal servers. It's that if you use a bare metal server, now you've got a box with a certain amount of CPU, RAM. You can only put one OS on it. So depending on what you want to do with that box, it's going to utilize now. Let's say that the box has um, 4 gigabytes of memory on it, and you want the box to do something that only requires 2 gigabytes of memory. And the thing you want the box to do requires an installation of Windows 10. Now you've got to use this whole box for this one task and have 2 gigabit bytes of memory just sitting there unused because you can't allocate that to something else. Everything else you want to do, you've got to do with Linux. Just this one thing you've got to do um, with Windows. So yeah, you can do that. You can have a dedicated physical machine to this task that you require Windows for, or you can have virtualization and you can have a dedicated machine that serves to virtualize other machines. So now you just virtualize an instance of Windows 10, and now you only have to use to allocate 2 gigabytes of memory to that machine, and you've got another two left over. So now you can allocate that to another machine, or just add that on top of the machine where you want to be more of a general purpose machine. So you don't have to. Um, it's almost another way to think about it, and I hope this doesn't confuse things. Is like when you subnet, when you have like a slash 24, and you turn that into a slash 25, and now you've got two networks, 0 through 127 and 128 through 255. So with just bare metal, it would be exactly like that. Now you've got these networks left over. You can't do anything with the extra unused host IPs. So if you just need one IP, you're going to have to throw away um, extra IPs because they subnet. Well, with virtualization, that's an instance where you can just allocate individual things for individual purposes, instead of having to be locked into large chunks of resources. In the never ending quest for more bang for their buck, people realized that virtual machines are still wasteful in terms of resources. The next logical step was to isolate an individual application into its own virtual environment. This was achieved by running containers within the same OS kernel. In this case, they were isolated at the file system level. Linux containers, LXC, and Sun Solaris zones were early examples of such technologies. Their disadvantage was that they were hard to use and were tightly coupled to the OS they were running on. The big breakthrough in container usage came when Docker started to offer an easy way to manage and run file system level containers. What is a Docker container? A Docker container encapsulates an application together with other software packages and libraries it requires to run. People sometimes use the terms Docker container and Docker image interchangeably, but there is a difference. The file system level object that encapsulates the application is called a Docker image. When you run the image, it becomes a Docker container. You can run many. Oh, okay, that makes sense. So the difference between a Docker image and a Docker container is like the difference between Windows 10 on a CD that hasn't been installed yet and Windows 10 up and running live on your computer. You can run many Docker containers, all using the same OS kernel. The only requirement is that you must install a server-side component called the Docker engine or the Docker daemon on the host where you want to run the containers. In this way, the host resources can be split and utilized in a more granular way across the containers, giving you more bang for your buck. Docker containers provide more isolation and resource control than regular Linux processes, but provide less than full-fledged virtual machines would. To achieve these properties of isolation and resource control, the Docker engine makes use of Linux kernel features such as namespaces, control groups or C groups, and union file systems, union FS. The main advantage of Docker containers is portability. Once you create a Docker image, you can run it as a Docker container on any host OS where the Docker server-side daemon is available. These days, all the major operating systems run the Docker daemon, Linux, Windows, and Mac OS. All this can sound too theoretical, so it is time for some concrete examples. Okay, so I want to do some highlights here. Let's highlight this. The main advantage of Docker containers is portability. That is something I think I'm going to need to know. Let's see here. Now, I also want to highlight something that showed up in uh, location 6859, which fortunately seems to be failing to load. And if I go to location 596, okay, I can't. So unfortunately, I didn't save my bookmark, but I mean, I just started a few pages into chapter 11, so I should be able to find my location without too much difficulty. I'll give it a few more seconds here. Looks like it's completely dead, so I'm gonna hit the refresh. There we go. And then we'll go to the furthest. Oh, yeah, we'll make this the furthest red location. This is where I wanted to. Yeah, yeah. So then we'll highlight this as well. Okay, and then we'll bookmark here and remove a stale bookmark if there is one. Now, it looks like there was an update to this that actually removed some of the vital tools I was using every day when I did this. But it looks like I can just click here, hopefully. Yeah, okay. And now, okay, there we go. And let's remove the stale bookmark. So here's a stale bookmark. We'll remove that. All the notes, that's going to be important. We don't want to remove those. All right, we're good to go. So I'm going to take a short break. When I come back, we'll do the real world examples.